Hi, my name is Rachel Housley, and this is going to be my video of my lab for Chem 1412, Factors Affecting Reaction Rates. So this lab's purpose is to observe and explain the effects that different variables will have on a reaction rate. And for this example, I will be doing the iodine clock reaction. The effects I'll be looking at are concentrations of different reactants, temperature, and adding a catalyst. So I have added 0.05 molar potassium iodide, 8 drops, into the top left well. I've added 2 drops of 0.1 molar hydrochloric acid and 4 drops of 1% starch solution, in addition to 0.01 molar sodium thiosulfate. I am about to add the hydrogen peroxide and begin to time. The first reaction took approximately 35 seconds to turn dark blue, so I will be decreasing the number of drops of sodium thiosulfate. I am now repeating steps 1 through 10 of the calibration tests. I have only added 7 drops of 0.01 molar sodium thiosulfate to this second well right here, and I am now going to add the 0.4 milliliters of hydrogen peroxide. This second trial took approximately 27.31 seconds to turn completely dark blue, so I will be decreasing the number of sodium thiosulfate drops to 5. For the third trial, I decreased the number of drops of sodium thiosulfate to 5, but it still took 24 seconds approximately, so the next one I'm going to decrease down to 4 drops. The fourth trial took approximately 20 seconds, so the calibration tests are complete. I will now be performing the same procedure using the number of drops located in data table 2. For trial 1 and 2 of activity 2, I calculated the average time of the reaction to be 20.19 seconds and the rate to be 0.0495. I will continue a similar procedure and calculating the rates for each of the next trials. I have collected my data for the effects of potassium iodide concentration, and I'm now moving on to the effects of hydrogen peroxide concentration on the reaction rate. I am about halfway through testing the effects of hydrogen concentration on the rate of reaction. I made a 75% HCl solution by adding 15 drops of 0.1 molar HCl and 5 drops of pure water, and I made a 50% HCl solution by adding 10 drops of hydrochloric acid and 10 drops of pure water, and I made the 25% hydrochloric acid solution by adding 5 drops of hydrochloric acid and 15 drops of pure water. Okay, so I have added the starch solution, hydrochloric acid, the sodium thiosulfate, and potassium iodide concentrations to each of the test tubes and place them in an ice water bath, a room temperature water bath, and a hot water bath. The hot water bath is 53 degrees Celsius, the room temperature bath is 25 degrees Celsius, and the cold water bath is 4 degrees Celsius. So they will be sitting here for 5 minutes, and then I will add the hydrogen peroxide to see the reaction rates from the temperature change. To pre-equilibrate the hydrogen peroxide, I have added it 0.4 milliliters of it to these test tubes marked with the white tape and added them to the varying water baths. Okay, so I'm now going to combine the reactants and time the reaction. Temperature appears to play a large role in the rate of reaction, as the cold water bath produced a significantly larger reaction time than the room temperature water, whereas the hot water created a much faster reaction. For the reaction with copper 2 sulfate, I saw a decrease in reaction time as more drops of copper 2 sulfate were added.